So this is also like TGA number one. You'll have a problem like this. But, the first thing we have to do is do what to this system? Yeah, we have to turn it into a matrix. And that part's pretty easy, right? Everyone should be pretty good about just translating the coefficients and the uh, constants, right? All right, so before we kind of get into this problem, let's talk about this. So to solve this into RREF, reduced row echelon form, we want to have ones in the diagonal, and then we want the other ones around it to be zeros. This last column here can be anything, but we want the diagonals to be 1 and everything else to be zeros. And we can do 3 row operations to achieve this. We can swap rows. We could multiply a row by some scaling value, negative, positive, or even a fraction. And then we can also add or subtract rows together. So those are the 3 things that we can do: swap, multiply, and then add rows together. All right, so our goal when doing these, we want to make the top left a 1. So after we make that a 1, we want to make everything below it a 0. Once we achieve that, we want to make, ideally, we want to make this a 1 next, and then make everything above and below it a 0. And once we achieve those things, we then move on to the next diagonal, and we want to make this a 1, and then make everything above that a 0. So generally speaking, that's the order that you want to work these problems in. Sometimes we're unable to do exactly that. And the recording from 9:28 at noon, I do a problem, which is actually this problem on this previous page. This problem here, I do work this one out. And this one, we weren't able to do that. So we had to kind of do this pathing, and I do talk about it. I'm going to just kind of write on this right now. We do this pathing where we start here and then we get that a 1, and then we go to this one, make that a 0, make this a 0. But then we were unable to make that 2, like a 1. So then we had to go over here and make this a 0, then make this a 0, then make that a 0, then make this a 1, make this a 0, and then make this a 0. So a lot of, I wouldn't say a lot of problems, but this problem, we had to kind of follow that pathing. And I think the module kind of does that too on some problems. But I do demonstrate that on 9:28 at noon recording, so check that out later. This one, I already worked it out ahead of time, and it's actually pretty nice. We are able to make this a 1, which already is a 1. That's nice. Make these zeros, then go to here, make this a 1, make these zeros, then go to this, make that a 1, and then make these a zeros. I also like to say that I believe on your TGA number 1, you can also do that. You shouldn't have any fractions. I made the problem a little easy. And these just take practice. So, all right. So step 1, we make this a 1. Do we have to do anything to this problem? The TGA is part 2. It's number 1 on your TGA for unit 2. All right. So again, do we have to do anything to make this top left element a 1? No, which is kind of nice, right? It's like, let's say like row 1 and row 2 were switched, and that we would have a 2 here, right? We could just we could swap 2 rows. Like I could even for fun, I could even swap row 1 and row 3 right now because they're both 1s. I don't know why you would want to do that, but we could. All right. So next, and again, guys, these problems, there's more than one way to approach them. So I'm going to lead you down the path of how I do them, and the way that I do them may not always be the best. I hope it is, but you may see a different way to approach these than I do, and that's fine. But like I said, I like making this a one, then I like making these zeros. So um, and when you make these zeros, we are always going to use this row that has the one. So we're always going to use row one to combine with row two and row three in two different operations to make these zeros. So kind of think about this. What's the row operation that I can do to combine row one and row two together to make that a zero? So Lizeth says multiply row one by -2 and then add it to row two. Natasha, do you agree with that? Yeah. I think that is a great choice. I think that's what I did too. So, um, yeah, I did the same thing. So I would like you just take say about 30 seconds. I want everyone to do this operation and write your new matrix. And then, there's only three of us here. So um, when you do finish that, give me a green check so I know that we're ready to talk about what we get. Isaiah, still working? See, you're tabbed out. Okay. So remember, we're only doing this first step. We're not doing the entire problem. All right. All right. So which rows don't change? So the work here we have here, which rows don't change? All right. Yeah. So it looks like two of you say 1 and 3. Yeah, the first and the last. Yeah. So remember, when you combine this operation, when you add, subtract two rows together, you only change the second rows. So I like to go ahead and just write the ones that aren't changing, and that way I avoid making the mistake of somehow changing those numbers. Also, even though we're multiplying row one by -2, we're not actually changing it permanently. We're only doing this for the actual operation part. So on your paper, I didn't show my math, but we're doing -2 times 1 is -2, and then -2 plus 2 gives us our 0, which is what we wanted, right? That was the whole point of doing this, was to get that element to be a 0. But don't forget, we have to do it for every other element, right, in this row. So we're going to do -2 times -1 is positive. I'm sorry, wrong row. -2 times 1 is -2. And then -2 plus -1 is -3. And then go to the next one. -2 times 1 is -2. -2 plus -1 is also -3. And then the last one, -2 times 8 is -16. -16 plus -5 is -21. All right, how did you three do on this? So I'm guessing you're talking about the TGA, Lizeth? Yeah, I'm okay with this. So whatever I'm showing you on the screen, I am okay with on your TGA. So, if you're showing kind of like what I'm doing here, you're not showing the little nitty gritty stuff, right? That and some of my examples I do show that, but like today I'm not. I'm okay with going to the setup, and then if as long as you show this, and then you obviously have the matrix represent what you did, I'm okay with that. Um, just be careful because if you do what I do and you do it in your head, that's fine. But you might make a mistake and you can't see it. Like you won't be able to see your mistakes. And then when I grade this, I do like to see where your mistake was because then what I do on when I grade this part of the TGA, if like what you're doing is good, but you're making like you made like an adding mistake. I'll circle where your mistake was. Like, hey, this is where your mistake was. Remember you get two submissions, so um, you can fix it. And the more you show, the more I can comment of this is where you made a mistake, and then from that point on, obviously it wouldn't be right. But I'm okay with this. All right. Anyway, all right. Sorry for my long explanations. Yeah, it's a simple question. I give you like a 2-minute response or answer. Anyway, sorry. All right, next. Remember, our goal is to make that a 0. So, what do y'all think? Well, remember, so what's our next step? What's the next operation? -1 times row 1 plus row 3. Yeah, I think that sounds good, right? Because -1 times 1 is 1. Sorry, -1 times 1 is -1, and then -1 plus 1 will give us a 0. So, yeah, I do agree with you. So, we're going to do that next. Um, which rows don't change? Yeah, 1 and 2. So, again, I like to just write those rows down to show that we don't change them. So, go ahead and find the elements in the third row. Just let me know when you are done with that. Isaiah, you should probably use paper and pencil versus your computer. Usually writing is faster. And if you want to use you're like I see you're kind of tabbing to a different screen to do your math. If you want to do it on your own time when you're doing your test, that's fine. But save time. Let's use paper today. Do you have a writing tablet or touch screen to do that, or using your mouse? Oh, so using your mouse. Yeah, that sounds terrible. Yeah, let's use paper and pencil so we can keep the speed today. Good. Good. You don't need one. Yeah, I don't think I had my first phone until I was either a junior or a senior in high school. Probably because they were way too expensive. I had a pager, a beeper when I was a freshman and a sophomore. Yeah. And I think junior year, I bought my own phone and paid for my own service when I was a junior or senior. One of those Nokias with the face plates you can change, and it had like a black and white screen. Yeah. What a great phone. All right. What did you get for your four elements? 0, -2, 1, and -2. Yeah, I think that sounds right. Okay. All right, we got column one done. Yeah, so we achieved this first column. We got this to be a 1, everything else to be 0. So now what do we want to do? Like, what's our next goal? Not the operation, but what are we trying to do next? What is the next operation? Or not operation. What is our goal next? Are we done? Or we're trying? Okay, yeah. So we're trying to get a 1 in row 2, column 2. Yeah. So yeah, both of you are correct. Yeah. Our goal is to try to make this a 1. Now, sometimes when you look at this, you might look at these two rows, and you might say, hey, if I move row 3 to row 2, so if I swap row 2 and row 3 to, and then I could do something to it. So sometimes that might be the case, but looking at this, how can I make this a 1? And I can think of two different ways right off the bat to make this a 1. Well, you just can't add 2. So you can't just add 2 to our entire row. That's not a valid operation. You can remember, you can swap rows, multiply by a scalar, or you can combine two rows together. So row 3 minus row 2. So remember, we changed the second one. So if you did -3 minus -2, that becomes -3 plus 2, makes it a -1. So that's close. So we could actually do that, and then maybe multiply row 3 by -1, and then that'll make that a +1, and then we could swap row 2 and row 3. So that requires three operations, right? And that's okay. It's remember, there's more than one way to approach these. Um, some ways might take more operation, so maybe that thinking might take you more. Um, I could think about doing. What about doing row 3 minus row 2? So we're doing 0 minus 0 is still 0. -2 minus -3 makes it -2 plus 3. So it makes it a 1. So row 3 minus row 2, I'll write that in chat. Row 3 minus row 2. Oh, wait. Jerry, oh, you said that. Oh, I wrote it backwards. Yes, Lizeth, you are actually correct the first time you said it, and not after I just said it. I read it as row 2 minus row 3. My fault. I'm a little blind. But yes, that would also work. We could do row 3 minus row 2. 0 minus 0 is 0. -2 minus -3 is +1. 1 minus -3 makes it a +4. And then -2 minus 21, -21 makes it a +19. Yep. So we could do that. We could. That's not how I did it, but if you want to do that, you can. It's just if you do it that way, the work from that point on will be different than my work, and that's okay. But I went ahead and I did what Lizette's thought of. I noticed that all, in row number 2, that all numbers um, are multiples of 3. So that means that 3 can go into all of these numbers evenly. So that's why I multiplied row 2 by -1/3. 0 times -1/3 is still 0. -3 times -1/3 is +1. Same thing, +1. And then -1/3 times -21 is +7. But doing row 3 minus row 2 will also work. We're just going to have different numbers for our row 2. And then your work from that point on will be a little different, but the answer in the end will still be the same. All right, everyone good? Okay. All right. So once we made this a 1, what do we do next? So we want to make row 1, column 2 a 0, and we want to make row what? A 0. So row 1, column 2 a 0, and make row 3, column 2 a 0. So yeah, we want to make we made this a 1, so now we want to make this a 0 and make this a 0. All right, so what operation can we do to make, let's start with row 1. How do we make this a 0, but still keep that a 1? Negative row 2 plus row 1. Anybody else? Natasha, what do you think? You agree? Okay. Yeah, and that's what I did too. Yeah, negative row 2 plus row 1. All right, so let's everyone quickly do that. Once you finish it, what did you get for your row 1 elements? Same. 1001. Yeah, I think I did too. Yep. All right. So what's next? So 2 times row 2 plus row 3. Yeah. Yeah, I think that's right. So remember, once you make this a 1 like we did up here, we're going to use this row, right? We're going to use it both times to make the elements above and below it a 0. Just how over here we made this a 1, well it was already a 1, but we used it twice, row 1, to make the rows below it a 0. So we use row 1 here, we use row 1 here, make these a 0. And then once we made that a 1, we use row 2 times to make the elements above and below it a 0. So what did all of you get for the elements in row number 3? All right, so let's take a look at this. So we got disagreement in 2 places, and that's fine. Saying 0, 0, 3, 12. Okay, let's take a look. All right, so we did 2 times, remember it's 2 times row 2 elements plus our current row 3. So we're going to have 2 times 0 is 0. 0 plus 0 is still 0. I agree with that. 2 times 1, use my pointer. So 2 times 1 is 2, and then 2 plus negative 2 is 0. All right, so we are all in agreement of the first 2 elements in row 3. Right, and then we are going to do, okay, I see you in chat saying that you see your mistake, and that's good. We're doing 2 times 1 is 2, and then 2 plus 1 gives us 3. Yeah. And then 2 times 7 is 14. And 14 plus negative 2, or in other words, 14 minus 2 gives us 12. Yeah, very good. Very good. All right. So check this out. We have a 1 here. We got zeros below it. We have a 1 here. We got zeros above and below it. So what's the next thing that we should try to do? One third times row 3. Anyone else want to agree with her? Yeah, that's really, I think that might be the only thing we can do. Yeah, we couldn't combine, like we couldn't say, hey, let's multiply row two by I don't know, -2 and then add it to row three, because then we would actually have like -2 plus 0 is 2 here. So then we would have a 2, and then we would have a 1, and then, we're going backwards, right? Whatever you do, you don't want to make these zeros change from that. We want to keep those 0. So, at this point, um, you know, what everyone chose, multiplying by 1/3 is really the only choice we have. So yeah, row one and row two don't change. And then what does row three become? 0014. Yeah. Okay. Um, what's the next operation? Or, you know, once we make this a one, we want to make everything above it a 0, right? Well, that one's already done. Yeah, looks like that. Row one is already done. So how can I make row two? How can I make that a 0? So -1 times row two plus row three. So let's talk about the operations here. Remember, we are trying. So which row are we trying to change? We're trying to change row two. So what both of you wrote, you put row three last in the operation. So remember, whenever you have one row plus or minus another row, the second row listed is the one that gets changed. So you can see how that's a problem, right? All right, so let's try that again. Oh, Isaiah, so what you wrote, they're different. Uh, um, so yeah, those are still very different. Like row three minus row two versus negative row three plus row two, they are different. But actually, do they both work? They don't both work. Yeah, only one of them is correct. Natasha, what do you think? So remember, we're we're going to use row number three, right? That's a one. We have to use this. So I'm going to write this down. So we're going to use row three. And then we have to do something, we're combining it with row 2. So that is definitely the order we have to do. Row 3 before row 2. Now, are we going to Oh, I need to multiply row 3 by something first. And let's look at these. Let's go back here. So whenever we used, this one to change these, if you notice, look, we are always adding row 2 in this case. We are adding row 3. Oh, down here, we are adding row 1. We are adding row 3. Did we ever subtract here or here? No. No. So if we check the pattern here, it's so if we don't subtract here, here, or here, here, do you think we're going to subtract here? Yeah, probably not, right? Probably not. You're probably not going to subtract. So I'm going to go ahead and just put a plus sign between them. All right, let's also look back at something else. When when we used row 1 to make the stuff below it a 0, did we ever multiply that second row by some scaling value, whether it's here, here, or here, or here? Did we ever multiply it? No, it was a straight add to row 2 or add to row 3, right? So do you think we're going to have to multiply this row 2 by something before adding it? Yeah, probably not. So if anything, right, going back to, where we did it here and here and here and here, we always multiplied that row that had the one we're working with by some number, whether it was a negative number or a positive number, right? So going over here, we're probably going to multiply row 3 by some number, whether it's positive or negative. Because as of right now, doing row 3 plus row 2 is 1 plus 1 0. Yeah, it's not. All right. So with all that said, what do you all think? What should the operation be? Well, yeah, it's got to be negative 1 plus 1, right, to make it 0. But so what is, yeah, so negative 1 times row 3 plus row 2 is correct. Yep. Yep. So yeah, it's going to be negative 1 or just negative row 3 plus row 2. So everyone quickly do that. All right, Lizeth, you agree with those two people? Good. 0103. I think that sounds right. Yep, 0103. Is the problem finished? Are we in reduced row echelon form? Yes, yes, we are. So that is the answer in RREF form. Now, in the ordered triplet form, what is the solution to our system? Because on your TGA, I do want you need to write it from. I want to see it in this form and also in the ordered triplet form, also known as like coordinate form, I guess, right? Yeah. 1, 3, and 4. Yeah, hopefully I typed it right. 1, 3, and 4. Yep. 1, 3, and 4. And guys, on your TGA, when you finish, oh, by the way, just a hint, your TGA, your answer will just be nice integers. You will have no fractions in your final answer. So if you watch this, there you go. If you get fractions, you messed up. Also, we can always take these answers, X, Y, and Z, and we can plug it into every single equation to verify it works. And it does. If you plug in all three of those numbers to every equation, it works every time, which means we got it correct. So unfortunately, we can't graph a three-dimensional system in Desmos, and it won't show us. At least I don't think we can. Maybe we can. I don't know. I never tried, honestly. Does it work? Has anyone actually tried it? Um, I don't know. I'm actually kind of curious now. I feel like it should do it. Oh, no, it doesn't look like it can. It makes us have some slider or something. I don't really know what's going on. Oh wait, I don't understand what's going on in this problem. All right, yeah, I don't think it does it. Yeah, okay. Okay, anyway. Yeah, it doesn't seem to do it. And that's okay. So really the way to check your answer is just to plug these back into the original and make sure it works every time, and it does. All right, so this problem was solved in 1, 2, 3, 4, 5, 6, 7 operations. So it took 7 operations to solve this in RREF form. The one on your TGA, I think, is actually, I think I did it in 8 operations. I'm going to double check. I'm curious now. Um, Answer key. So number 1 on the TGA, I did it in 1, 2, 3, 4, 5, 6, 7. I did it in 8 operations. So it could take you more. Like I think 8 might be the minimum. But if it takes you more than 8, it doesn't mean you're wrong. It just maybe you just chose the less optimal path, and that's okay. I also made the problem. I think I made it kind of easy. If you do it right, you shouldn't have to deal with any fractions the entire time. At least I didn't have to deal with fractions when I did it the way I did it. So hopefully that helps. So the three of you that are here, was that helpful going through this problem together? Hold on, let me see the questions in the chat. Let's see. Is there a pattern to reduce to the matrix? Is there a pattern to reduce? What do you mean? Tasha, what do you mean by is there a pattern to reduce to the matrix? Hello? Oh. Like, are you supposed to go in a certain order to reduce the numbers? Um, so sort of yes. The way that I like to do it, so going back to the original, I like to make the top left a one. So that is priority number one, is make that a one. Next, we want to make everything below to zero, which we did. After you do that, we go to the next diagonal, and then our goal is to make this a one. After that's a one, you make everything above it and below it a zero. After that, we go to the next diagonal, and we make that a one. And then we make everything above or below it a zero as well, which we did. So that's the ideal way of doing these. Sometimes we can't do that because then we have to deal with fractions. So if you watch the recording from 9:28 at noon, I go through this problem right here, which is actually a quiz question. This is on the quiz, and I went ahead and someone asked me to do that, so I just made a recording out of it. So if you get this on your quiz, well, you watch that recording, you'll have the answer. But I do go through this problem from the quiz, and the path that I was forced to do to avoid fractions was to make this a one, make that a zero, make this a zero. I was unable to make this a one without creating fractions in my work. If you're okay with fractions in your work, it's okay. You're just going to have fractions, right? You have to think about everything in fractions. But when I did this problem on the 28th, instead of trying to force that into a one and then causing these to be fractions, what I did was I made that a one, I made that a zero, I made this a zero. I couldn't make this a one without making fractions. So instead, I went to this number and I made this a zero first. And then so once I made that a zero, I tried to go back to make this a one, but I still got the same problem. If I went from this making it a zero to this making it a one, I would create fractions here and here. So I said, all right, I can't do that yet. So then I went from this zero, and then I made this a zero. And then once I made that a zero, I tried to go back to this to make it a one. Again, I couldn't without having to deal with fractions. So I just went to this number and I made that a zero. Once I made this a zero, I was able to make that a one without having fractions. And then once that was a one, I then used this row when this had the one in it to make that a zero. And then, I'm sorry, going back to here. Sorry, I made this a one. Remember, diagonals, right? I said zero earlier. So again, make that a one, make that a zero, make that a zero, make that a zero, make this one a one, make this one a zero, make this one a one, make that one a zero, make that one a zero. So a little confusing if you don't actually see the problem written out, but watch the recording. It'll make more sense once I go through it, because I do spend a long time working this problem out and explaining it. So it's a good watch. Does that help, Natasha? The one in your TGA, I made it rather simple. If you did the same pathing we did on this problem on your TGA, you'll be fine. It works out real nice. So you don't have to deal with fractions unless you do something really crazy and you just make wrong choices, I guess, or not wrong choices, just less than optimal choices. All right, I'm gonna go ahead and stop the recording. I hope this helped. And remember, everyone watching this, I'm available. So if you do want to go over like a concept, like somebody and that's here right now asked me, if I could go over this problem today, and I said sure. So I made a class connect session, and I asked this person what time was good for them, and they told me at noon. So if you're in the same situation, and you want to have like a class connect session, like a whether it's one-on-one or it's I open up for the entire class, and then if you guys see it as being, it's optional, of course, and then if you want to, I title it accordingly, RREF example, you can join. So reach out if you need help. Don't wait to the last minute. So if you ask me for help like a day before the locking, well, the Friday before the locking date, for example, which is this is not the case. I don't know if I'll be able to help you in time. But yeah, this is totally fine. Just guys, just reach out and help if you need anything. Okay.